Okay, so what we're going to do is we're going to kind of put together everything that we have done with a few examples. Okay, so these are just extra problems to help us all out. Okay, the first one I'm going to say is, find all the zeros. Okay, and here is our polynomial function. So f of x is equal to x cubed plus 10x squared plus 33x, and then plus 34. Okay, so that's what we got going on thus far. Okay, we could try factoring it, right? And all that wonderful good stuff. Okay, and there's a lot of different methods that we can use. So one of the things it wants to find all the zeros. So I know that n is equal to 3. So that means I'm going to have 3 zeros, aka I'm going to have 3 factors. They might be complex, they might be real. That's the beauty about that. So the first thing I'm going to do is I'm going to find my p's and q's. So my p value, remember, is your constant term, which is 34. And my q is my leading coefficient, so it's a 1. I love when it's a 1. And I want to list all the factors of 34. So I have 1 and 34. That's an easy one. And I have 2 and 17. Those should be all my numbers. Remember, I have positive and negative, so negative 1 times negative 34 gives me positive 34. And I only have one factor, 1, and that's 1. So if I want to list all my p's and q's, you are going to take all the positive and negative versions of those. I'm going to take all my p divided by every single q. So I'll have plus or minus 1, plus or minus, I'm going to put it in order, so this will be 2, plus or minus 17, and then finally plus or minus 34. Okay, so disregard the noise in the background. So my suggestion when you're testing out numbers, we don't want to necessarily test out the largest numbers. We probably want to test out the smallest numbers first. So remember, you're going to use synthetic division. So you're going to have 1, 10, 33, and 34. Now, for the sake of time, I already know a number that is going to work, but to be honest, I probably would have started with a positive or negative 1. But I know that negative 2 is actually going to work out. At least it should. Let's make sure. So we are going to bring down the 1, and this will give you a negative 2. This should be an 8, which means that this is a negative 16. And then this should be a positive 17. And 17 times negative 2 is negative 34, which gives you 0, which is what we wanted. So negative 2 worked out. Yay! Okay. So what do I now know? I know that f of x is going to be an x plus 2. So that is a factor. So that's a 0, but this is a factor. And then remember, highest degree, it's always 1 less than the highest degree. So this becomes x squared, and then plus 8x plus 17. The next thing we want to recognize is that we'd want to try to factor the trinomial. Again, we could try, if you wanted to, we can try more p's and q's. Unfortunately, this isn't factorable, so nothing is actually going to work out. So what do we have to use? We have to use our lovely quadratic formula. So x is equal to the negative b plus or minus the square root b squared minus 4 times a times c all over 2a. So sometimes we do have to come back to that. So let's see what we get. So this will give you a negative 8 plus or minus 8 squared should be 64. We're going to multiply 4 times 1, which gives us 4, and then 4 times 17, which gives us 68, all over 2 times 1, which gives us 2. Simplify, so this gives you negative 8 plus or minus the square root of -4 all over 2. So that's going to be your complex number, which is lovely. I'm going to bring it down over here. So -8 plus or minus the radical of -4 is 2i all over 2. And remember that 2 gets to be distributed to both the terms in the numerator and denominator. So -8 divided by 2 and 2i divided by 2. This will give you -4 plus or minus I. So there are our other zeros, right? So if the problem asked you to find all of the zeros, these are what you would say, right? These are our zeros. We have a -2, we have a -4 plus I, and a -4 minus I. If the problem said find linear factorization, our problem would look something like this. X, we can say x minus a -2, right? This will be x minus -4 plus I, and then this will be x minus parentheses -4 minus I, which is the same thing as saying this, x plus 2, x plus 4 minus I, and x plus 4, and then plus I. Okay, so it kind of brings everything together a little bit. Okay, so I want to show you what this looks like on Desmos. So we're going to notice that we will cross the x-axis at a -2, but that is the only place that we will cross it at. So let's type this in. F of x is equal to, I believe I said x cubed, and then plus 10x squared plus 33x, and then plus 34. Okay, so we can, let's see if I can move my screen. There you go. You can see the equation now over here. And now notice power of 3. So if we're describing end behavior, we know it's a positively leading coefficient. So as x approaches -infinity, y approaches -infinity. As x approaches positive infinity, y is approaching positive infinity. Notice that we only cross it at one spot. Okay, so again, we're just double checking that we did our math correctly. So beautiful. All right, so let's go ahead and try one more example. And an extra problem. So this will be an extra example. We'll say number 2. And that will read as this. H of x is equal to x to the power of 4 plus 6x cubed plus 10x squared plus 6x plus 9. Okay, so beautiful. So the first thing I want to do is I want to find all my p's and q's. Power of 4, I should have, so 4 zeros, 4 factors. So we're just going to say find the zeros. Okay, so p is equal to 9. Q is equal to 1. Again, lovely number. So 1 and 9, and 3 times 3, so we don't need to write that twice. So here are all of our lovely P's and Q's. 1 divided by 1 is 1. 3 divided by 1 is 3. And 9 divided by 1 is 9. All right, so we want to test out some numbers. Power of 4. So again, for our sake of argument, I'm going to test out the first number that I know that's going to work, and that's a -3. So 1, 6, 10, 6, 9, right? 4, 3, 2, 1, 0. So let's see how that works out. Bring down the 1, multiply 1 by -3, add those numbers together, I get 3. This will give you -9. Add those together. I get 1. Multiply. -3. Add. 3. Multiply. 9. Notice that it worked out. Yay! There's one of our zeros. Next time you find a 0, you want to use these new numbers. So remember that this is now x cubed plus 3x squared plus x, and then plus 3. So if I multiply that guy by x plus 3, right? That'll be, oops, not F, it's H, right? So again, I want to focus on this guy. Notice that, again, I could set up my P's and Q's, but the factors of 3 is only 1 and 3, so kind of can cancel off that guy. Notice that 1 and 3 are still on there. My suggestion is always start with the same 0, because remember, you might see that lovely bounce in there. So I'm going to try -3 one more time, but with my new numbers, 1, 3, 1, 3. Bring down the 1, multiply it together, -3. Ooh, cancels out. Love that. That will give me 0, 1, -3. It also worked out. Beautiful. So that means that there's a bounce at this problem. Okay? Good things to know. So what do I know now? I know that this used to be x plus 3 times x plus 3, or aka x squared. And then I have, or x plus 3 squared. Now I have x squared plus nothing. So this will be x squared plus 1. So last one, I need to find the zeros, is I'm just going to set x plus 1 equal to 0 and solve. So I'll take the square root. So this will be plus or minus the radical of -1, which equals plus or minus I. So all of our zeros are this: -3, -3, I, and -I. My factors, if I wanted to write that out, not that I asked you for that, but it would look like this: x plus 3, x plus 3, x plus I, x minus I. Ooh, almost ran out of room over there. All right, so let's see what this looks like again on Desmos. So that graph is up there, but let's go ahead and take it away. So I said x to the power of 4 plus 6x cubed plus 10x squared plus 6x plus 9. Okay, so again, we see this lovely bounce. Power of 4, so we know that's going to be up. So if I zoom out, right, it is doing this weird thing right here. That's okay. We don't need to worry about that information. How we can also check to see if we actually had eyes. I wonder if it will work on Desmos. Let's check it out. If I put it into factorization, so if I say x, what did I say the answers were? X minus 3, so that'd be x plus 3, and x plus 3. And then this would be an x minus I and an x plus I. So notice that Desmos does not recognize the I, right? So the I would have to be a slider. So they don't recognize imaginary numbers, which is a shame. That's not fun. So unfortunately, we can't test out to see if that actually worked. If it ended up giving us a radical, we could, but since it doesn't, unfortunately, we can't do that. Okay, so those are some extra examples, kind of putting it all together.